Yeah, good evening. Oh, I okay. I'll share the email. Hello, my voice is clear. Okay, I will share the direct link to you. Okay, I'm just sharing in the chat box. You can access those PPT using that link. Okay. Hmm. Yeah. Yeah. I will share the common link that will contain all the content of week wise content basically. Okay. I have just shared the link. Just you can try. If you are unable to access, just let me know. Okay. Are you able to access now? So can I so that I can move forward to the next assignment? Oh, okay. Now I am starting the next assignment. Hope you got the access using the link I have given in the chat box. Can you hear me? Okay. So hi everybody. This is the assignment 2 of this course. Okay, so this is the assignment 2 of the course coordination chemistry. I am Anuj Kumar and I am working as a Prime Minister Research Fellow teaching assistant for this course, which is instructed by Professor Debasis Resar. And this is basically the course plan we have already discussed. Okay, so the same pattern I will follow in this assignment. First, I will show you the questions, and I'll wait for 2 minutes to get your answers, and thereafter I will explain the solution of those problems. Right. So here is a slide one containing two questions. Okay, just read carefully and tell me the answer. Okay, so okay. You can just type in the chat box. Okay, simple question. Terminology is used. That is, bidentate ligands can donate how many of lone pairs to the metal atom? Options are 1, 4, 2, and 6. Okay, and the second one is what type of ligand bipyridine is? It is neutral bidentate or anionic tridentate, cationic monodentate, or none of these. If you know the answer, just type. Okay, I got the answer C and A. Okay, fine. So here are the explanations for both the questions. Okay, as its name indicates, bidentate ligands are Lewis bases that donate two lone pairs. Okay, that is basically the bi is for two electrons to a metal atom. Okay, and similarly, if there is a donation of one electron, it will be monodentate, and for n6 lone pair we can say tetradentate and hexadentate and so on. Okay, and second one here you can see the structure of bipyridine. Okay, so it is a neutral bidentate ligand because here are two nitrogens, and it can donate, they can donate their lone pair to the metal atom, right? Okay, apart from that, you can see it is a neutral ligand. Okay, so the answer for first one will be 2, and the second one will be neutral bidentate, right? Okay, so I am moving forward to the next questions. Okay, the first one is you have to uh, determine the geometry of this complex. Okay, so the copper metal is there, and this is terpyridine, basically uh, one bipyridine bipyridine ligand is there, and it is connected uh, one ligand molecule. So basically it will be bipyridine plus pyridine. I will show you the structure. Okay, And second is, what is cyclam? Okay, it is classified as a crown ether. Its IUPAC name is 14811 tetra azacyclotetradikene. It binds the metal ions through the four nitrogen atoms, or all of these options are correct. Okay, so if you know the answers, please tell me, because all these things you have already read in your classes. B and B. Okay, so before I go to the explanations, can you just please confirm the link? You can access the link now for the presentations. Okay, that's fine. Okay, so I'm going to the explanations. So somebody wants to join. Okay, so you can see here, this is the structure for this terpyridine, a tridentate ligand. Okay, so as I have already said that it it is basically bipyridine plus pyridine. One pyridine molecule is there, and this is bipyridine. It's connected through a pyridine molecule, right? So you can see here there are three nitrogen atoms. Okay, and it can easily donate its lone pair to the central atom. Okay, and each pyridine, that's why each pyridine is coordinated with the metal center through this nitrogen atom and another two ligands, because we are discussing about this complex. Okay, so these two another two ligands are attached with copper. Okay, so the coordination number will be 5, because 5 ligands are attached to the metal atom, and the geometry of the complex will be square pyramidal. Just see the structure. This is copper, and if I write this one, this nitrogen. Okay, one Cl and another Cl is here. Okay, so the structure will look like this. And second is about cyclam. Basically it is a as a crown ether. Okay, and IUPAC name is 148, uh, let me do the numbering here. 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14, right? So 1, 4, 8, and 11 tetra eza, because four nitrogen element is there, and this is a cyclic compound. Okay, so cyclo tetradecane, right? And it is classified as a crown ether when it binds metal ions like this in its cavity. So these four atoms are directly connected to the metal atom through coordination bond. Okay, so here are four statements, three statements. It is classified as a crown ether. It is correct. Its IUPAC name is this. It is also correct. It binds the metal ion through the four nitrogen atoms. So all these options are correct, right? So moving forward, yeah, moving forward to the next two. So this question is basically related to the cavity of 18 crown 6 ligand. Okay, so it can bind the specific metals in its cavity, because size of this metal affects the basically the compatibility with this ligand. Okay, so some specific metals are there which can only lie in the cavity of this 18 crown 6, right? You have to just identify that which metal is that. Okay, and the second one is you have to choose the correct statement for this ligand. Okay, basically box is bisoxazoline ligand, right? I will show you the structure and we'll discuss. Okay, so these are four statement. It is an achiral inorganic molecule. Box is the bisoxazoline, contains three oxazoline units, and the coordinated complex of these ligands is useful for asymmetric catalysis. And last is none of these. So let me get your answers first, and that after that I'll explain. Okay, so here is the explanation for the first one. So 18 crown 6 is an organic compound with this formula, and the IUPAC name of this is 147 10 13 16 hexa oxacyclooctadecane. Basically, at these positions, you will find the oxygen atoms. Okay, and it functions as a ligand for some metal cations with a particular affinity for potassium cations. Okay, so here present other cations like these are not fitted within the cavity for their small sizes, right? Because these three cations are very small in size, that's why they do not fit in the cavity of 18 crowns. Here you can see the typical structure. Here is the this is the basically potassium positive ion that is basically fitted, and this is the structure of 18 crown 6. So this is the structure basically of the complex which is forming here. Okay, right? So the explanation for the second one, I was asking about bisoxazoline. So this is the bisoxazoline ligand. It is the spacer, basically a CS2 molecule. CS2 linkage basically is a spacer here, and similarly in this case it is pyridine molecule. That's why it is called the pyridine box ligand. Okay, so they are basically the chiral organic molecules having the C2 symmetry. Okay, and the coordinated complex of these ligands is used extensively in asymmetric synthesis, because here you can see one the basically the configuration or the reaction in which this ligand is involving. It is basically used for the formation of enantiomers. Okay, so that product formation basically depends upon the stereochemistry of these R groups. So that's why it is a well-known ligand which is extensively used in the asymmetric synthesis. Okay, so the answer for the first one is this potassium, and the second one is this the coordinated complex of these ligands is very useful for asymmetric catalysis. This is not correct because it is a chiral molecule, right? And second one box is the bisoxazoline contain not three, it contain two oxazoline units. Okay, yeah. So moving on the next two. that is which metal ion in which oxidation state is present in hemoglobin. This question is related to basically bioinorganic chemistry, okay, in which you read about hemoglobin, myoglobin, and the porphyrin rings, okay. So basically, mainly the coordination chemistry is the fundamental for the development of bioinorganic chemistry, right? So you have to just identify which metal is present in hemoglobin, okay. Okay, so just try to do it at your own. I'll wait for your answers, and after that I'll explain. You know, iron is present in hemoglobin, so you can just exclude all other options from here, and you can choose the first one. But I'll discuss the structure of hemoglobin, and let make you know what iron, how iron is present in the hemoglobin, right? And same here, this question is also related to the hemoglobin structure. Basically, you have to tell the fifth coordination site is fulfilled by the coordination of which nitrogen. Okay, if you know the hemoglobin contains which amino acid units, okay, or protein chain, you can easily tell the answer. Okay, so I'm just moving to the explanation section. So here you can see it is the structure of hemoglobin. Basically, hem B is written here. This R1 group is vinyl and R2 is methyl. Okay, and this acid. Okay, so when you will see this type of structure where R1 is acid COOH and R2 for vinyl, so that is called the hem B. Okay, and hem group. What is hem group? This four pyrrole rings. One pyrrole ring is here, one pyrrole is here, and there are four pyrrole rings, and nitrogen of these pyrrole rings are connected to the iron center, that is basically in the plus 2 oxidation state. Okay, the same thing is written here in hemoglobin. A heme group consists of an iron held in a heterocyclic ring known as porphyrin. Okay, basically this ring is called porphyrin. Okay, and this consists of four pyrrole molecules cyclically linked together by methane bridges. Okay, methane means, okay, so methane is, this one is the methyl linkage. Okay, so what is basically the summary of this structure? You are having four pyrrole rings, and nitrogen, four nitrogen of each pyrrole ring is connected to the iron center, and basically in between the pyrrole, two pyrrole rings are connected through this unit, that is basically you can say methane bridge. Okay, and this beta 2 beta 1 alpha beta is basically it is called as two halves are there. Okay, so there are two halves. This one is alpha beta half and another alpha beta half. So basically what happens, Hemoglobin basically contains 4 units of such type. Okay, and these units are interconnected with the salt bridges. Okay, salt bridges is basically the protein. If I consider this linkage and another linkage, right? Okay, so what happens here? This amine convert into this group, and acid group is converted to this. So this interaction just form the salt bridge, which basically binds such type, basically the 4 molecules. It is the binding force for these 4 molecules. Basically hemoglobin is the tetramer of myoglobin, right? So the single unit is called myoglobin and the tetramer is called hemoglobin. Okay, and in the second one, the question is related to oxy and deoxy hemoglobin. Okay, so yeah, in oxyhemoglobin, as its name indicates, the iron center is connected to the oxygen molecule. Basically, you can see here the oxygen molecule is connected. Okay, and in deoxyhemoglobin, basically here one the fifth site is basically connected with the nitrogen of this histidine amino acid unit, and sixth is connected here to the water molecule, right? But when oxygen is connected here, it just replaces this water and connected to the metal center, because the binding affinity of oxygen is higher than water. Okay, so here you can see the iron atom is lowered from the heme group's plane without the binding of oxygen. Okay, so what it does, without oxygen this iron just do not fit in the cavity of hemoglobin. It just above the plane. This distance is basically around 0.45 to zero point 0.6 angstrom above the plane of this hemoglobin. And when oxygen is connected to this ring, basically to the you can say the metal center. Okay, the size uh, contracts such that it basically fits to the cavity of hemoglobin. So iron is basically now is not above the plane of hemoglobin, it just fitted to the cavity. Okay, so the iron atom is flushed with the heme group's plane with the binding of oxygen. Okay, so, in both oxy and deoxyhemoglobin, 4 of the coordinated sites of iron are occupied by the nitrogen of porphyrin ring, right? And the fifth site is occupied by the histidine residue, this nitrogen of histidine amino acid unit. Okay, and the sixth position is occupied by weakly bonded water molecules for deoxyhemoglobin and oxygen for oxyhemoglobin. Okay, so the question asks about the fifth coordination site. So basically, that is coordinated by the nitrogen of histidine residue. Understood? If you have any confusion, please just type in the chat box. Okay. If it is fine with you, just confirm. I will go forward. Okay. Thanks. Yeah. So I am moving to the next one. Okay. So which one is not considered as heme protein? I have already told you which is the heme group. Okay. So you have to just identify among these molecules, okay, which does not contain the heme group basically. Okay. And the next one you have to uh, basically you have the nomenclature. You have to do the nomenclature of the this complex. Okay. One is cation here, another one is the anion. So basically, yeah. So follow the same rule. First go with the cation, and then name the anion basically. Okay. Okay, just I am waiting now for your answers, please. Okay, A is the answer. Second, right. I have already given you the hint by showing the oxidation state of the cation and the anion, right? So just try to solve. I have already discussed the myoglobin. You can consider the monomer unit of hemoglobin basically, right? So hemoglobin is the tetramer. So you just consider the single unit, and you can tell whether it contains the hem group or not. So if I talk about this one, you just first put the name of the cation. Okay, so the four amine ligands are there, four ammonia ligands are there. So it will be tetraamine platinum for cation and tetrachloroplatinate. Basically, it is an anion. So after the metal's name, it will the eight will be added, right? Okay. So here is the explanation. So heme proteins are a strongly colored protein which is due to presence of heme moiety. The heme moiety consists of a substituted proto-porphyrin ring containing a liganded iron atom. Non-heme protein contains strongly bound functional iron atom attached to sulfur, but they, no, they do not contain porphyrins, right? Somebody, mic, please mute your mics, please. Okay, so I was discussing about, you can see here the structure of hemirathine. Okay, so basically this molecule is known for oxygen transfer, right? So you can see here there are this iron is 3 and 3 hexa coordinated, right? Three bonds are coordinated with the nitrogen of histidine amino acid unit, and one is basically this is the glutamic acid unit. Okay, and second one is the spartic acid. Okay, so here you can see there is no porphyrin ring. Okay, it is just directly hexa coordinated with the nitrogen of histidine amino acids unit and other amino acid units. Okay, and this hydroxide that is basically coming from water molecule that is already present there, right? Basically the specific point you can note here, right? This iron is pentacoordinated, right? and this is hexa coordinated. Okay, because here only two histidine amino acid units are connected. Okay, so I was talking about it is used for the oxygen transfer, right? So how it binds the oxygen atom, right? First, in the pure form, these two irons are in the second oxidation state. So what it just oxidized to plus 3 and donates electron. Okay, and this O2 molecule accept this electron and converts into this form. Okay, right? So this form is connected here, and further it bounds through the hydrogen bond. Okay, so this is basically the mechanism. You will read this mechanism more deeply in the bio inorganic chemistry. Okay, so what was the question asking? The You have to just put identify which molecule does not contain the heme protein. So hemitrythine is that molecule that does not contain this moiety. Somebody is asking what type of ligand is tetrapyrrole. It is tetradentate ligand basically because it contains four nitrogen. Tetrapyrrole is basically, you can say, the porphyrin ring. Okay, the four nitrogen four nitrogen atoms are just donate their lone pairs to the central metal atom, and its denticity is 4. Okay, I have shown the structure of this porphyrin ring in my last slides. So the next I have already explained related to the nomenclature of this complex. So the next is how many technon molecule. This is the structure of TA tetra acyclononane is required to bind a manganese metal ion, and what will be its geometry. Okay, just try by yourself. In the class, this complex is already discussed. Okay, see. Okay, so if I consider it, the this like this trigonal phase. Okay, and this is manganese. So the structure looking like this one. Okay, so the structure just looking like this. So you can see here the coordination number of this manganese metal, it's 6, right? So how many molecules of this techn will contain the three atoms of nitrogen, right? Okay, yeah. So the two molecules of this taken molecule is required for binding to the manganese metal. Okay, and what will be the oxidation? Sorry, the coordination number, that will be six, basically. So what it will be? It will be the octahedral complex. For six coordination number, the octahedral complex formation will be there, and two moles or two molecules of this ligand will be required, right? So I have just indicated the structure here of every ligand. Basically you have to identify the donor atoms and answer the question. So answer is just with the question. Here is the structure. You have to identify the donor atoms and tell me the answer. What will be the denticity of benzoyl acetone? And second one is the ligand system present in vitamin B12 is. Basically you have to tell the name of this ring. Okay. Okay, so in the first one you can see there are two oxygen atoms which can easily donate their lone pairs. Okay, yeah. So yes, so the denticity will be 2 in this case, right? And I am waiting for your answer to the next one. I think you are already familiar with this structure. That is basically the structure of vitamin B12. Cobalt atom is there, which is coordinated with four nitrogens of this ring. You have to just identify the name of ring. This is basically not a porphyrin ring. Okay, here you can see this ring is already reduced, and you can see here is a methine unit. Here is also a methine unit. Here is also a methine unit, but here is a missing methine unit, right? So in the classes you have read about the chlorine ring. Okay, but in the chlorine ring, this this linkage is, I think, not missing. Only this one is ring is reduced. Okay, so this type of ring is called corin. Okay, so the specific ring that is present in vitamin B12 is called the corin ring. Okay, if it was porphyrin ring, so it just porphyrin just contain this methine unit here, right? And none of the pyrrole ring is reduced, right? So the right answer will be this one. This the next questions is related to the IUPAC nomenclature. You have to just identify the cation and anion and name accordingly. Okay, add prefix and suffix accordingly. Okay, first identify the oxidation state. After that, identify the cation and anion and just name it. Okay. B and D. Okay, I'm just waiting for others because this is the second last slide of this session. Okay, first I'm getting the answer B. Anyone else? Okay, so this is the cation, that is sodium plus, right? And this will be PCl6 minus 1. So what will be the oxidation state for phosphorus here? That will be plus 5, right? So just name it sodium. There are six ligands, that is hexachloro, and because phosphorus is in plus 5 oxidation state and it is anion, so 8 will be added after it. So answer will be sodium hexachlorophosphate. Try for the other one, please. Here, ethylene diamine is there. So basically, the dye you cannot use here because dye is already included in the ligand's name. So that's why you have to put bis before the name of this ligand. Okay, right? So before that, you have to determine the oxidation state first. So what will be the oxidation state here? That will be plus 3. Okay, so just name. So chloro bis ethylene diamine, just put in the alphabetical order. Okay, so chloro bis ethylene diamine nitrito, because it is uh, connected through the oxygen. Okay, so chloro bis ethylene diamine nitrito cobalt in the 3 oxidation state. So this will be the right one for this. Okay, so somebody was asking about this porphyrin ring. Okay, so you can see the structure here and you have to just tell me. Yeah, this one. Yeah, done. Okay, so I have discussed, I think, 2 or 3 times about this porphyrin rings. You have to just tell me how many pyrrole rings are present in the porphyrin ring. Basically this is a porphyrin ring. So it was a very easy questions. So four pyrrole rings are present in the porphyrin ring. Okay. So if you have any questions apart from these problems or related to these problems, you can just post later on the in the discussion forum. I will later on answer those queries. Okay. So this was all about the assignment 2 of this course. Thank you very much for the attendance. Right. Okay, 4 is the answer. So thank you everyone for attending this session. I'm just leaving the meeting now. Thanks. Yeah, please. Pencil design. Okay. Yeah, yeah. Your voice is just post your queries uh, in the discussion forum. I will answer there more elaborately, right? Okay, pincer ligands about two lines. You are asking about the pincer ligand. Basically, the pincer ligand is most often an anionic two electron donor to the metal center. Okay, you just see about the terpyridine ligand. Basically, two uh, pyridine bipyridine molecules are there and they connected. So basically, these type of ligands are called pincer ligand. There is a basic rigid backbone and other the donor atoms basically supported by the these backbones. Okay. If you okay. Okay, thank you all.